So let's look at a few checkpoint questions here and open it up for any questions you may have. And then we will see how much more we can get into today. So I'm going to give, let's say, 2 minutes for you to look at these questions, think about responses, and write those responses down. It doesn't have to be in too much detail, but definitely try to write or record a response. And then we'll share after 2 minutes. Okay, 1 more minute. All right, final seconds here. Okay, so let's discuss the answers here and feel free to respond in the chat or just share aloud if you would prefer. So the first question, what is a twitch? How does an isometric twitch differ from an isotonic twitch? All right, so in the chat here, excellent. Twitch is contraction in muscle fiber. Yes, that is true. So it is a single contraction in response to a single action potential. It's pretty much the unit of muscle contraction. So what happens to the muscle as a response to a single action potential, right? And then going on to respond here further. So an isometric twitch is constant length, which is perfect. Isotonic twitch is constant tension. Yes, that is absolutely correct. Just to kind of expound on that some more, an isometric twitch, the length is the same. The muscle does not actually shorten. The muscle length doesn't change because the load is too heavy and the load is never overcome, right? The isotonic switch is where we see the load being picked up because the contraction, the tension being produced is enough to compensate, enough to actually overcome that load. And that is why the tension is the same, right? So the tension is the same because we have achieved a point of tension that is enough to overcome the load. And so at that point, we no longer need to generate more tension. We can level it off because we can overcome that load. All right, excellent. Number 2, what is the size principle? So what is the size principle?
Hold on a second.
Sure.
The size principle is a judgment based on how heavy a load is. So the example you gave, it's the body's judgment on how heavy a load is. So for example, if you're lifting up like a tissue box, that's not going to take a lot of contraction, and it's going to be like smaller motor muscles, like you said. And if it's a heavier load, it's going to take a lot more motor muscles, and the body's going to judge it as heavier. But it can also sort of bite you in the back because you can assume an object is heavy, or you can assume an object is lighter than it actually is, and it can cause disorientation.
True. Yes, absolutely correct. Well said. So yes, it's basically a discernment of light to heaviest, right? And so we want to recruit the smaller units first. These are used to do smaller work, to lift lighter objects, and then we want to recruit larger objects later on. And someone is also responding in the chat here. It's the order of motor unit recruitment related to the size of the motor units, which is absolutely correct. Just to expound again, the order being from small to large, right? Smaller amounts of work, smaller motor neurons, smaller motor units, smaller muscle fibers, and then we recruit larger ones for more heavier, more strenuous activity. So awesome, well said, perfectly correct. Moving on to the last question here. What is the meaning of the term velocity of shortening? So what does velocity of shortening mean? Any thoughts on this one? What is velocity?
I think velocity of shortening ties into the last one, because there needs to be a certain amount of speed in which muscles contract to lift a certain type of object. I would say, I could be wrong, but I would say a lighter object doesn't need as quick of a contraction, because your body isn't like trying to build up muscle, for lack of a better term, to like lift an object. So if it's heavier, the velocity is going to be faster. I would.
Let me correct that before you continue. So the velocity is actually going to be faster for lighter objects, right? Because it's going to take less time to kind of get that machinery going, to actually do the contraction, the cross bridge cycling. It's less time for that to happen because we need less force for a lighter object.
Okay, so I was assuming, like, I was imagining like the actual muscles and not like limbs. Like, right. Okay, that's probably where I got confused. So, okay.
Yep, so you're kind of along the same lines, you just had it kind of flip-flop. So we don't need, or rather we need less time, we don't need as much time to produce the amount of tension that's needed if the load is relatively light, right? Because remember, thinking about how much force is required, right? And if we only need a small amount of force, then the velocities to get that force going is much quicker.
Okay, that makes sense. So it's the speed in which muscles lift and work with things.
Yes, absolutely correct. Yes, the speed of which the muscle can contract and overcome that load.
Okay, thank you.
Yep, sure. Let's see some other responses here in the chat. So the rate of change of the distance is shortened. Yes, so the rate of change of the distance is shortened. Another way to express that, the velocity of shortening decreases with larger loads. Absolutely correct. So the quickness, the speed with which you can contract that muscle is less, right? It's going to take a longer amount of time to contract for a larger load. And then you're going to have a shorter velocity for a lighter load. Right, so let's say that again. So a shorter velocity for a lighter load, and then a larger velocity for a heavier load.